Hello everyone, this is Shankha Subrasanial on behalf of S-Cube's classes. I'm really thankful to you all for your overwhelming response. The amount of views, the amount of likes, the amount of subscriptions, the way it is going up, the feedbacks that you people are giving, I'm really encouraged and motivated. Today, I'll talk about evaporation, the factors affecting evaporation. We'll also talk about the Bose-Einstein condensate and plasma in this lecture. I hope you'll be enjoying this. So let's begin this session. When a liquid is left exposed to air, its volume decreases gradually. This is due to evaporation. In this process, some of the liquid of the surface turns into vapor or gas and mixes with the gases in the air. Thus, when the liquid turns into vapor, it is said to evaporate. We can now define evaporation as the process of a liquid changing into vapor even below its boiling point is called evaporation. Evaporation of a liquid can take place even at room temperature, though it is faster at higher temperatures. Whenever or whatever be the temperature at which evaporation takes place, the latent heat of vaporization must be supplied whenever a liquid changes into vapor or gas. The wet clothes dry due to evaporation of water present in them, and rainwater puddles also dry up because of evaporation of water. Common salt is also recovered from sea water by the same process of evaporation. The process of evaporation can be explained the way I'm going to do it right now. So let's begin with the process. Some particles in a liquid always have more kinetic energy than others. This is quite obvious. So even when a liquid is well below its boiling point, some of its particles have enough energy to break the forces of attraction between the particles and escape from the surface of the liquid in the form of vapor. Thus, the fast-moving particles or molecules of a liquid are constantly escaping from the liquid in the form of vapor. The evaporation of a liquid depends mainly on four factors. The first one is the temperature, the second is the surface area, third the humidity, and fourth the wind speed. We will discuss all these factors in details, but we'll go one by one. The rate of evaporation increases on increasing the temperature of the liquid, or in other words, the rate of evaporation of a liquid increases on heating. When the temperature of a liquid is increased by heating it, more particles of the liquid get enough kinetic energy to go into the vapor state. This increases the rate of evaporation. Thus, the rate of evaporation of a liquid can be increased by heating it. The rate of evaporation of a liquid becomes maximum at its boiling point. The rate of evaporation increases on increasing the surface area of the liquid. So if the surface area of a liquid exposed to air is increased, the rate of evaporation of the liquid increases. For example, if the same liquid, say water, is kept in a test tube and in a china dish, then the liquid kept in the china dish will evaporate more rapidly because more of its surface area is exposed to air. In our daily life, we spread out the washed wet clothes while drying to increase its surface area for the rapid evaporation of water present in them, which leads to quicker drying of the clothes. After rain, the wet roads dry quickly because the rainwater is sprayed over a large area of the road. This gives the particle of water a greater chance of escaping from the liquid. From this discussion, we may conclude that the rate of evaporation of a liquid can be increased by increasing the surface area of the liquid. The amount of water vapor present in air is represented by a term called humidity. When the amount of water vapor present in the air is small, the air appears to be dry and we say that the humidity is low. On the other hand, when the amount of water vapor in the air is large, the air appears to be damp and we say that the humidity is high. So, humidity of air tells us the degree of dampness of the air. When the humidity of air is low, then the rate of evaporation is high and water evaporates more readily. Under these conditions, sweat from our body evaporates readily and we feel cool and comfortable. The wet clothes dry quickly under the condition of low humidity of air. When the humidity of air is high, then the rate of evaporation is low and water evaporates very slowly. In the latter part of summer, the humidity of air increases. People sweat a lot in such weather, but the sweat from our body does not evaporate readily, due to which we feel muggy and we feel hot and uncomfortable. The shirts get stick to our body. This is a very common experience that we people have. This type of weather is experienced during cloudy days as well during the rainy seasons and in areas which is very close to the sea, which we call as coastal areas. The wet clothes take a long time to dry when the humidity of air is high. The rate of evaporation of a liquid increases with increasing wind speed. When the speed of wind increases, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surroundings. This increases the rate of evaporation of water. The washed wet clothes dry more quickly on a windy day because evaporation is faster due to the high speed of the wind. We have already studied that whenever a liquid evaporates, it must be supplied the latent heat of vaporization. The cooling caused by evaporation is based on the fact that when a liquid evaporates, it draws, that is, it takes the latent heat of vaporization from anything which it touches. By losing heat, this anything gets cooled. Keeping these points in mind, we'll now give some examples of the cooling caused by evaporation. If we put a little spirit or maybe petrol at the back of our hand and wave it around, the spirit evaporates rapidly and our hand feels very cold. This is due to the fact that to change from the liquid to the vapor state, spirit requires latent heat of vaporization. The spirit takes this heat of vaporization from our hand. The hand loses heat and gets cooled. This is an example of cooling caused by evaporation. Another very common example is during hot summer days, water is usually kept in an earthen pot called pitcher or matka to keep it cool. At many places, especially in villages, people often sprinkle water on the ground in front of their homes during the hot summer evenings. This water evaporates by taking large latent heat of vaporization from the ground and surrounding air. By losing heat, the place becomes cool and comfortable. Perspiration or sweating is our body's method of maintaining a constant temperature. We should wear cotton clothes in hot summer days to keep cool and comfortable. In fact, a fan increases the rate of evaporation of sweat or moisture from our skin and makes us feel cool and comfortable. Let us perform an experiment to show the presence of water vapor in air. There is always some water vapor in the air around us, which we cannot see. The amount of water vapor in air keeps on changing. Water vapor comes into the air from the evaporation of water present in the ponds, lakes, rivers, and oceans. Water vapor is also given out by plants by the process of transpiration, where the water vapors evaporate from the leaves. Animals give out water vapor when they breathe out air. Land also gives water vapor on being warmed by the sun. All this water vapor goes into the air around us. Let us now focus on the experiment that I was just telling you. The presence of water vapor in air can be shown with the following experiment that I'm going to discuss. Let us take a steel tumbler and put some well crushed ice into it. Let us wipe the tumbler from outside with a piece of clean, dry cloth so as to make its outer surface completely dry. Let us now allow the ice containing steel tumbler to stand undisturbed for around, say, 5 minutes. A large number of tiny drops of water appear on the outer surface of steel tumbler. Now, why does this happen? This happens because the air around the steel tumbler contains water vapor in it. When this water vapor comes in contact with the cold outside surface of the steel tumbler, they condense to form tiny drops of liquid water. So, the formation of drops of water on the outside surface of a tumbler containing crushed ice shows the presence of water vapor in air. Scientists now say that there are actually 5 states of matter. We are aware of the ones that we have discussed till now: solids, liquids, and gases. But along with these, there are 2 more states of matter: plasma and Bose-Einstein condensate. In the upcoming slides, we'll talk about these 2 states of matter. Plasma is a mixture of free electrons and ions. Plasma is considered to be the 4th state of matter. It occurs naturally in the stars, including the sun. Inside the stars, the temperature is so high that the atoms break up. Some of the electrons break up from the atoms, converting the rest of the atoms into electrically charged particles called ions. This mixture of free electrons and ions in a star is called plasma. The sun and other stars glow because of the presence of plasma in them. Plasma can also be made on the earth by passing electricity through gases at very low pressure taken in a glass tube called a discharge tube. The fluorescent tubes and neon sign bulbs form plasma when they are switched on. A fluorescent tube may contain helium gas or some other gas, and a neon sign bulb contains neon gas. When electricity is passed through a fluorescent tube, the gases present in them get ionized to form plasma. This plasma makes a fluorescent tube or a neon sign bulb to glow. In 1920, an Indian scientist, Satyendranath Bose, did some calculations for the 5th state of matter. On the basis of these calculations, Albert Einstein predicted the existence of a new state of matter called Bose-Einstein condensate. In short, we can write it as BEC. The 5th state of matter, called Bose-Einstein condensate, was finally achieved by 3 scientists, Cornell, Cottrell, and Wyman of USA, by cooling a gas extremely low density, about 100,000 of the density of the normal air, to super low temperatures. Well, this brings me to the end of lecture number 4. This is a series of lectures where we were discussing about matter in our surroundings. Till now, a lot of people has already written about their queries to me. In case you have still not clarified your doubts, you may write to me at scubesclasses@gmail.com, or you may WhatsApp me your queries at the given numbers on your screen. It will be a privilege on my part to answer to your queries. Thank you so much.